Okay, the second one. All right. For the second one, you have the circle, and you have O, that is B, and that is G, and A, and C. So you always have to remember, if this one is 1, that angle is twice. And they have given to you that this angle at the center at O is 80. Now what will B be?
Maybe 40.
Hey?
Will it be 40?
Yeah. B is equal to 40 degrees because the angle at the center is equal to 2 times the angle at circumference. You know that one, eh?
Yes, ma'am.
As we do this, we revise the theorems, eh?
Yes, ma'am.
Happy with that one?
Yes, ma'am.
Now number 3. I have the diameter, né? Is it right?
Yes, ma'am.
And this is A, and this is C, and then you have C there. Angle on the diameter is always equal to, angle in a semicircle is 90 degrees. You know why?
No, ma'am.
Because 180 is a straight line. So the angle, this is the angle at the center. So C is the angle at circumference, so that is the smaller one, so it will be half, and that is then 90. Nee.
Yes, ma'am.
So then you can just say that C is equal to 90. Angle at center is equal to 2 times angle at circumference. Okay, no problem with that one, eh?
Yes, ma'am.
Number 4, you have this, and then you have like the butterfly, né?
Yes, ma'am.
You have C, and you have E, and you have A, and you have D. This is 30 degrees, and this is 20 degrees. This is E, and this is D. Okay, when it's like a butterfly, it's not like alternate angles, né? So that means that this angle is equal to that one. And this angle is equal to that one. So then you just write E is equal to 20 degrees and D is equal to 30 degrees. Angle in the same segment. Eh?
Yes, ma'am.
Angles in the same segment. You agree with me?
Yes, ma'am.
Okay, then we come, the one that's very close to this one. The one that's very close to this one is this one. Angle at center you agree? Then they do this. Now let me rub it out. Let me do it nicely. We have this circle. Can you see that it looks very similar?
Yes, ma'am.
But the difference is now that there's only 3 on the circumference of the circle. Here you have 1, 2, 3, 4.
Yes, ma'am.
So this is the angle at the angle at center and angle at circumference. So they say this is C. Now let me do another coloring. So here they say this is O, this is C, and the one they want is F, and the other one they want is G. And they say that this angle is 78. Okay.
Yes, ma'am.
Now first that you see is F is the smaller one, eh? So if this one is 78, it is divide by 2 is 39 degrees.
Yes, ma'am.
So let me do that one. So we're busy with this one and this one, eh? So F is equal to 36 degrees because it's angle at center. I'm not going to write it out, okay?
Yes,
Just to save time.
Yes, ma'am.
But now if you look at G, it's another story. Because this is now what kind of triangle?
Maybe.
An isosceles triangle, you see?
Yes, ma'am.
Okay, kom ons maak daai in 'n pers. So, and what do we call these ones? This is A and B. So now, triangle, or wait, how do they say it? So we will say OA is equal to OB because it's the radii of the circle.
So, ma'am, this is B.
B. Okay, sorry, Michael. All right. So that means then you have 180 minus, no, I just think how to state it now nicely, ne?
Yes, ma'am.
I would say, therefore, triangle OAB is isosceles, and the reason that they want is angles opposite equal. Nee, nog nie. We have to say now in OAB is isosceles, therefore you see, I've done it a long time ago, so I just want to write it clearly as they want it stated, you know.
Yes, ma'am.
So angle OAB is equal to angle OBC. Now we say angles opposite equal sides. Ne? So then you have 180 minus 78 is 102.
Yes, ma'am.
So 102 divided by 2 is 51. So therefore angle G is 51 degrees. Okay.
Yes, ma'am.
Then we come to the other kind. Now we're going to do that was all angles in a circle.
Yes, ma'am.
Now we come to the next section, and that is quadrilaterals. Alright. Okay, you have it. Then you have your quadrilateral. And that is P and S, Q and R. So this is 112 degrees. That is 90 degrees. That is H. And that is I. Okay, the first one that you have is that the exterior angle of a cyclic quad is equal to the opposite interior angle. So therefore, H is equal to 112 degrees. Exterior angle of cyclic quad. Ne?
Yes, ma'am.
Now, you know another thing. Let's do this one in another color. Now you see this angle. If you add those two, they will give you 180. You agree?
Yes, ma'am.
What is the theorem for that? Angle I plus angle 93 is equal to 180 because the sum of the opposite angles of a cyclic quad. Sum of, okay, now I have a shorter one. Opposite angle of a cyclic quad is supplementary.
Yes, ma'am.
Opposite angles of a cyclic quad is supplementary. You agree with me?
Yes, ma'am.
So if that's 93, then it will be 107.
Ma'am, if you minus it.
Yeah. 180 minus 103 gives you 107. Because you take that one over to that side.
Yes, ma'am.
You have it.
Yes, ma'am.
Do I waste your time?
No, ma'am.
Okay. That is about the quadrilaterals. It's only two theorems. Then we have tangents. Okay, we have to explain this one. If you have a tangent, the tangent is perpendicular to the radius, ne?
Yes, ma'am.
Okay, and then if you have a tangent and you have a line there, this angle here, if you have this angle here, this line is next to that angle, do you see?
Yes, ma'am.
So this angle is equal to that one. Angle in the opposite segment, ne? Or if you have this angle here, you've got this side.
Yes, ma'am.
And if you go from that side, you come to that one. Do you understand that?
Yes, ma'am.
Sure.
Yes, ma'am.
Okay. So now we have the circle, we have the tangent, we have A, C, and E. then this line is parallel. It's not in all sums like that.
Yes,
But
ma'am.
this one is now given parallel. So you have here K 65 and you have J. Okay. Because the lines are parallel, do you see?
Yes, ma'am.
You can say J is 65. J is equal to 65 degrees because,
Alternate angles.
okay, I just want to write down here, I forgot all the letters. A, B, now this is D and E. This one is D. Because it is alternate angles and the lines that is parallel is BA is parallel to DE. Good.
Ma'am.
But now you have the tangent. This is now the tangent. And with the tangent you have that angle, then you look at that line, and from that line you come to this one. So what can you say?
That K is equal to 65.
K is equal to J is equal to 65. And then we write it's the tan chord theorem.
Yes, ma'am.
Okay.
Ma'am, if they don't give us the parallel lines and they say that we should prove that AB and DE is parallel.
Then if you find, then you will prove the angles equal. So if you have the angles then equal, then you know it is parallel.
Yes, ma'am.
Right. We come to difficult ones now. I just want to do the simple things before we do that. You make sure you understand that implication of this. That everybody learns the theorem, but not everybody understands the implication of the theorem. You see? So for number 8, I have this. That's not a nice circle, eh? And I have this, and I have this. Now that is O1. That is 150 degrees. That is B, D, C, A, and that is N. So now you can, do you see this is also a way of because, okay, this angle is 2 times that one, eh?
Yes, ma'am.
But this angle is 2 times that one. Do you see?
Yes, ma'am.
So now we first work out O1, and this is a revolution, or angles around a point, I don't know how you say. So we will say O1 is equal to 360 minus 150 is 210.
Yes, ma'am.
So O1 is equal to 210 because it's a revolution. Or you can say angles around a point. You understand?
Yes, ma'am.
So with other words, now we have worked out that that is 210. So now that angle is twice that one.
Yes, ma'am.
So with other words, this would be the half of that one, because the bigger one is always at the center.
Yes, ma'am.
So that is then 105. So M is equal to 105. because angles at center is 2 times angle at circumference. Alright, now we're going to move to more difficult ones, I think. I'm going to just choose them randomly.
Okay.
I hope I can do them. You think I can do it?
Yes, ma'am.
Okay, let's just say